Math Humans. We're going to continue our work with revolved solids today. We're going to do 7.2c. Today we're going to be talking about known cross-sections. So we're going to find the volume of a solid with a known cross-section. So this particular phrase is very important because your clue to know when to do this method is you'll see those words in the problem. So let's review what we've done so far. Basically, we've said that the volume of a revolved solid is equal to pi integral from A to B of the whole quantity squared minus the whole quantity squared and then dx. Okay. Important to notice is that our representative rectangle is perpendicular to the axis of rotation. So if we make our formula a little bit more official, it's going to be the integral from A to B of capital R of x squared minus little r of x squared and then dx. Remember that we could also have the volume is equal to pi integrating from C to D of r of y quantity squared minus r of y quantity squared dy, and that would be if we were rotating about a horizontal axis and rotating about a vertical axis. Okay, so now we're going to have a change, and I'm actually going to bring in pictures because I can't draw this. So now we're going to change the scenario. So now we're going to have our cross sections are going to be shapes other than circles. So if you'll think about what we've done so far, we took a shape and revolved it, and remember that with my beautiful artwork, it made a circle. So we had circles that we were finding the volume of. Well, now what we're going to have is other shapes. See if I can show you these. I just copied and pasted from your book because I can't draw that. But notice that, like right here, perpendicular to the axis of rotation, my cross-section could be a triangle, or in this particular shape, the cross-section could be a square. And so the words of the problem will always tell you what the problem is. Notice that your axes have been rotated. That's kind of cool if you're doing three-dimensional drafting. Alrighty, so now let's just move in and start talking about our work. So the volume with, I'm going to write known cross-sections, is going to equal the integral from A to B, A of x dx. So notice that there's no pi out front because no longer are our cross-sections necessarily circular. But with a known cross-section, I'm going to take the area and use whatever area formula is relevant and then dx. Okay, and remember that my cross-sections are going to be perpendicular to an axis, and this one would particularly be the x-axis because I have a dx, okay? And then I could also have the volume is equal to the integral from C to D, A of y dy. It just depends. There are a couple of things that I want to tell you that we're going to do. The very first thing that you're going to want to do is determine what I call the base. And that means it's going to be your top curve minus the bottom curve. Or if we have a dy, it's going to be the right curve minus the left curve. And this is going to determine the length of the side that you're going to use in your area calculations. The other thing that's really, really important to remember, because it will save yourself a ton of math, is that cool formula that we learned in pre-calc, that the area of a triangle, if you're given side angle side, is equal to 1/2 the side times the side times the sine of the included angle. And remember, you always have to be given side angle side. That makes these problems significantly easier because this is a glorious formula. So let's start in with examples, and I'm just going to write out the long words once so you'll know what they look like. This says find the volume of the solid whose base bases are bounded by the graph of y is equal to x plus 1 and y is equal to x squared minus 1, whose, and here's the key phrase, known cross-sections are a square, I was trying to think about my grammar, perpendicular to the x-axis. And I can't draw these for you, so I'm just going to apologize now. So I can show you what I do know how to do. So here's going to be my coordinate system, and I'm going to graph my two equations. So I have y is equal to x plus 1, so here's my 1, there's that guy. And then y is equal to x squared minus 1, here's my upside down parabola. So this is going to be the revolved region whose known cross-sections are squares. Okay? So the first thing that I'm going to do, besides find my point of intersection, that's a positive one, because my known cross-sections are perpendicular to the x-axis, that means that here's going to be my shape, and there's going to be a dx. So the volume is the integral from a to b, a of x dx. So the first thing that I'm going to do is I'm going to calculate my base. And when I do these problems, I write this out because I need to know that you knew how to determine the length of that particular side in your area calculation. So it's going to be my top minus the bottom. So it's going to be my top is the straight line, x plus 1 minus x squared minus 1. So this is going to be x plus 1 minus x squared plus 1. So it's going to be a negative x squared plus x plus 2. So that's going to be the length of my base. Well, I have squares, so the area of a square is equal to the side squared. And we use the terminology that I have right now. I'm going to say that it's my base squared. So now I can set up my integral, and again, we're going to do all of these in our graphers because I am assuming that you remember how to integrate. So the volume is going to equal, notice there's no pi, the integral from a negative 1 to 1 of a negative x squared plus x plus 2 quantity squared dx, because I have side squared, and that's going to be 8.1. So my volume is 8.1. Okay. The harder part on these is just setting them up, but if you remember our notation of the height of the rectangle, that's going to be how you determine your base. So let's do our second example. So again, I'm going to not write all the words now, so I'm going to have known cross-sections. My known cross-section is going to be an equilateral triangle. Okay. My equations are going to be f of x is equal to 1 minus x over 2, and g of x is going to equal a negative 1 plus x over 2, and I have x is equal to 0. Okay. So I want to find the volume. I'll write that down. The volume with a known cross-section, and my known cross-sections are equilateral triangles. So the first thing I'm going to do is I'm going to graph. So y is equal to, I'll do this one first. So my y-intercept is 1, and my slope is 1/2. So it's going to go that way. I'm going to label it as f of x. Sometimes it's important to label them so you remember which one's top, which one's bottom, which one's right, which one's left. And this one we're going to have perpendicular to the x-axis. I guess I should tell you that. Okay. The second equation is, here's the negative 1, and its slope is a positive 1/2. And this is going to be the region that is being revolved about the x-axis. Okay, and my known cross-sections are going to be equilateral triangles. Okay, so the first thing I'm going to do is I'm going to calculate my base. And the difference is going to be the top minus the bottom. So that's going to be, the top is, and I guess I should be consistent, f of x minus g of x. So I'm going to write 1 minus x over 2 minus a negative 1 plus x over 2. So this is 1 minus x over 2 plus 1 minus x over 2. And if I simplify that equation, I get 2 minus x, and I'm going to write that that's my base. So I'm going to use that cool formula that I talked about. So it's an equilateral triangle, which means that the angles are all 60 degrees. So my area formula is going to be 1/2 the side, which is a base, times the side, times the sine of 60 degrees. Okay? So this is going to be, here's the half. My base is going to be 2 minus x quantity squared. The sine of 60 is radical 3 over 2. So my area in terms of x is going to be radical 3 over 4 times my 2 minus x squared. So now I'm going to set up my integration. This point of intersection is 2. So my volume is going to equal the integral from a to b, a of x dx. So I'm going to integrate from 0 to 2. Here's my radical 3 over 4. It's a constant, so I'm going to pull it out front. I have 2 minus x squared dx. Push buttons on my grapher, and I'm going to get that the volume is equal to 1.155. So it's not as hard as it seems. This formula is the best thing since sliced bread, and it will save you so much time. If you don't remember that formula, then you have a lot of trig to do. All right, third example. So this time we're going to have the base of a solid is a circle with a radius of 4, and the cross sections, that's an E, that are perpendicular to the x-axis are squares. And of course, it's going to say, what's the volume? So again, this is my shorthand. So they actually don't give you an equation on this one because they're assuming that you remember the equation of a circle. So remember the equation of a circle located at the origin is x squared plus y squared is equal to r squared. So that means that our equation is going to become x squared plus y squared is equal to 4. And I'm going to draw this because even though it's super simple, sometimes these problems cause issues. So here's our representative rectangle, and they told us that it's a square. This distance, I'm going to use a different colored pen, is y, and this distance, really crappy drawing, is also y. If I solve this equation for y squared, I get y squared, bad math, is equal to 16, is equal to 16 minus x squared. Y is going to equal the square root of 16 minus x squared. And I'm only using the positive root because I just need y, and then I can double it. So the base is going to be 2 times y, which is what I've shown here. So that's going to be 2 times the square root of 16 minus x squared. They told us that our perpendicular cross sections are squares. So my, and this is a negative 4, this is 4, okay? So I'm going to integrate just this half right here. I'm going to integrate that first piece. So the volume is equal to the integral from 0 to 4 of the base side squared. So 2 times 16 minus x squared dx. And again, I can just push buttons on my calculator, and then I'm going to get the volume is equal to 341.333. So again, because I'm doing known cross sections, and they told me that my known cross section was a square, the area of a square is side squared, and in this case, this is my side, it's the base, it's 2y, and so then I squared it, okay? And remember, when we're doing known cross sections, there's no pi out front. Alrighty, That is it for today. I will see you soon.